Okay, the next machine is a brake, or the press brake. Now this is set up that this side is regular bends, this side is all kinds of custom bends and custom tooling, and this side is just flattening dies. In other words, that's the undo button for wrong bends. Okay, and so say if I'm going to bend this, so here you set it up on a digital gauge. Some machines have a manual gauge, which is just as good. So here I type in a bend, let's say 30. Okay, so it adjusts. Put it in for a bend. Now I can, as I said, I can undo it, but it's not going to make a perfect flat again, because this needs enormous pressures to make the metal flow again. So if you had to undo it and it had to be nicely done, you'll have to anneal it. You have to take a butane torch at least, heat it up to red hot, and then it will undo. If you just undo like this, it will leave a mark. There's a ridge here, and it is surprising that even with a 100-ton press, like the big press there, you can barely get rid of this mark. But if you anneal it before you did it, it will undo nicely. One reason is because it work hardens, so it's harder to flat. Now, what you'll notice a few things here. First of all, I'm using what's called a gooseneck tool instead of the regular tool, and I'll show you the profile. The gooseneck tool has this profile. The regular tool is just a V at the bottom. The advantage of this, it allows you to bend narrow channels, because you can bend, as I'll show you in a moment, if you wanted, in general with a brake, you can only bend the U, which is wider than its depth. Otherwise the U will interfere, it will hit here, okay? But if you want to bend a narrow channel, say 10 by 10 by 10 millimeter, if you have a gooseneck tool, the channel can end up with the last bend like this to wrap around, and you can make them a narrower channel. So since in prototyping, at least in what I do, a lot of parts are small, it's preferable to have a gooseneck tool so you can make narrow channels, yes.
Is that what that one with the hole in it is for as well?
The one with the hole is to make deeper channels, and this you have to make yourself with a water jet, and all these cuts are done with a water jet. So to save money, you buy one long bar, and then you cut it up with a water jet, and you have like a 1-inch piece, a 2-inch piece, a 3-inch piece, or actually if you're smarter, you do it in some binary order, so you have a minimum number of pieces, to get to any dimension you want. Okay, and then you make a few special pieces like the one with the hole, which allows you to bend a very deep U. Okay. Now something else which is useful is a table which you can make or buy. Okay, and the reason is sometimes you have very narrow strips. So if I had a strip like this, for example, okay, and I can only touch it to one stop, I don't know if it's square or not. So to bend narrow stuff, I need some kind of a table with marks. So this one goes like this. You don't have to make it as fancy as this. And now I can line it up with the marks on the table. Okay? So if I want so for example, bend the deep U, like I said before, like this. If I have this hole here, I can bend something which is deeper than it's wide. Okay, that's what this is for. Okay, good. Now, how thick a metal you can bend depends how wide it is. Because this press brake, this one is 24 tons. So 24 tons will, the limit will be to bend full widths about gauge 12, say a bit under 3 millimeter. So, and this is with this die. Of course, if you use a wider V, it can bend thicker stuff. So there is actually three parameters. One is the thickness of the material, one is the width, and one is the opening of the die. Because if you want to bend very thick stuff, you need a die with wider opening. So in order not to have to change tools all the time, the best thing is to leave it always with a 3/4 inch die, because this will allow you to bend quite thick stuff in narrow sections, and as I said, about 2.5 to 3 millimeter stuff on the full width. This is for steel. Aluminum, of course, you can bend more. Okay, so for example, this is 3.5 millimeter steel, so certainly there's no problem to bend a narrow piece with this die. Okay. Okay, now the brake comes with a rear adjustment if you want to bend less than 90 degrees, which is quite inconvenient because you have to run and adjust it. So I added a front adjustment, which is just an air valve which shuts off the air when it reaches the right depth. So if I want to bend, say, less than 90 degrees, let's say I want to bend 45 or something, I'll just shut off the air earlier. So say I can put it back this way. Okay. So that made a very light bend. I can go a bit more. Say. Okay, so basically I can adjust for other than 90 degrees by adjusting the valve, which is much simpler than dealing with a back adjustment. If you don't want a sharp bend like I had before, say if you wanted a radius bend, all what you have to do is bend first a piece of scrap and use it to give a radius to the die, sometimes just for aesthetics. You like radius ends, so you have a whole set of radius tools, okay, and usually it's a good idea to put magnets in them that they stick to this. So this one, I think the magnets fell out. So anyway, so you can still do it. So say if I want to bend this with a radius, I just put it in here like this, and I would have to hold it now because I don't have the magnets, and like this. Okay. So now it will give you a rounded bend. You want these fingers, of course, to be narrow, the way they are supplied with the brake, but if they are too wide, they cannot come in narrower than this beam. But if they are narrow to come in, when they are far away and you put in the part, you can miss the fingers. So a very useful modification is actually to put a sliding tube over the finger, so close by the tube slides back and you can come in with a very narrow finger to make very narrow bends, and if you're far away you have the whole area of the tube to rest on. So let me just point this modification out because it's very useful. So I'll just move it here to where we can see. So originally it comes with a round bar, but what you do, you narrow down the round bar as much as you want, and then you put a sliding tube over it, and the sliding tube stops exactly flush with the round bar. So you can actually push in this tongue all the way in, and the tube stays behind. A very quick demo about brackets. Brackets are very, very common. So if I want to make a right angle bracket out of this piece, I can do it like this, but then I find out the bracket is quite flimsy. So there's a few ways I can make it rigid. The simplest way is I just take a brace like this. I just bend the brace, spot weld it here, and the best idea is, because I'm not sure if that's accurate, I hold it against a square. I hold it against the square and spot weld here. So that's the simplest type of bracket. The second type of bracket is I just take a triangular stiffener piece, which I bend the two sides, put the triangular piece into the bracket and spot weld. Here I don't need the square because the triangular piece itself is bent square. Now, if you are short of space, and if you want to make very simple brackets which are stiffer, what you can do is you can bend into them a rib. So first let me bend the rib into it, and then I'll explain how you do it. So let's say I bend it again here, but this time I bent a rib into it. And the way it's done is I leave a space on the brake between two segments. It's desirable to minutely round the corner, and I put in a blade which has a rounded, just take it out, oops, I put in a hardened steel blade which has a rounded top. This has to be hardened, okay, and I put it in to be about flush with the die. So now, while it makes a bend, it also puts a rib in. Okay, and that rib is very, very simple and gives it immense stiffness. For example, if I take this thing now and squeeze it, or if I hold it like this and squeeze it, you can see that most of the flex will be at the unstiffened part. So if I start bending it down, you can see the unstiffened part bent, the two stiffened parts bent very little.